So, in this particular lecture, we want to study the complex form of Fourier series. Please note that earlier whatever form we are doing, that is a function of cos nx or sin nx form. Now, we want to see what is the complex form of a Fourier series, that is on the exponential form, how I can represent this particular Fourier series. So, for the complex form of the Fourier series, it is given that f x be a periodic function of period 2 pi. From here we will start and we will check what is happening. If f x be a periodic function of period 2 pi, then the Fourier series of the function f x can be written as f x equals a 0 by 2 plus summation n equals 1 to infinity a n cos n x plus b n sin n x. This already we know it, the Fourier series of a function f x, which is a periodic function of period 2 pi. Now, we know these two things, e power I n x, this is equals cos n x plus I sin n x, and e power minus I n x, this is equals to cos n x minus I sin n x. These two formulas we know it, e power I n x is cos n x plus I sin n x, and e power minus I n x equals cos n x minus I sin n x. So, that from these two equations I can express cos n x value and sin n x value in terms of e power I n x and e power minus I n x. From here I can obtain this thing, cos n x, this is equals to half into e power I n x plus e power minus I n x, and on the same way your cos n x, this is equals to half into e power I n x, this will be minus. So, it will be minus e power minus I n x. So, if I substitute these two values now of cos n x and sin n x in the equation 1, I have cos n x here, I have sin n x here. What I will do now? I will substitute these values of cos n x and sin n x, which I derived in the given equation 1. Once I am substituting this, then your f x can be written as f x equals a 0 by 2 plus summation n equals 1 to infinity into a n by 2 into e power I n x plus e power minus I n x. This is the value of cos n x plus b n by twice I. Sorry, I made a mistake on that case. Your sin n x will be equals to 1 by twice I into this thing. I am just writing here, please note this one. I am just, this will be e power minus I n x dx. So, what I am getting over here, a n into a 0 by 2 summation n equals 1 to infinity, a n into value of cos n x is half into e power I n x plus e power minus I sin n x, e power minus I n x, whereas value of sin n x, this is equals to 1 by twice I into e power I n x minus e power minus I n x. This I was missing in the last slide. So, please correct this one. This will be b n by twice I into e power I n x minus e power minus I n x. So, that this equals, I can write down this directly, I can write down f x equals with some new coefficients c 0 plus summation n equals 1 to infinity into c n into e power I n x plus c of minus n, say I am denoting e power minus I n x, where your c 0 is a 0 by 2, c n will be half into a n minus I into b n, and c of minus n, this will be half into a n plus I into b n. Simply by using these two, I am getting this, I am denoting this by the new constants C 0, C n and C minus n, where C 0 from the earlier equation I can write it a 0 by 2, C n will be half into a n minus I b n, and C of minus n will be half into a n plus I of b n. Now, your C 0 is nothing but a 0 by 2, and this equals what is a 0? 1 by pi into minus pi to pi f x dx. This we know it, minus pi to pi f x dx. So, this I can write it 1 by twice pi minus pi to pi f x into e power 0 into I x dx. So, that e power 0 is 1. So, since I am just substituting the value of a naught here, a naught is 1 by pi minus pi to pi f x dx. On the same way, your what is your C n? C n equals half into a n minus I into b n. This is equals to 1 by twice pi into minus pi to pi. I am substituting the value of a n now, minus pi to pi f x cos n x dx minus I into minus pi to pi f x sin n x dx, f x into sin n x dx, and this if I write down again, I can write it as 1 by twice pi minus pi to pi, your f x you can take inside. So, that cos n x minus I sin n x dx. From here I can write down this by putting f x over here. So, this will be equals to 1 by twice pi, I can write down, or minus pi to pi f x into this cos n x minus I sin n x. This is nothing but e power minus I n x. So, your C n becomes ultimately 1 by twice pi minus pi to pi f x into e power minus I n x dx. So, basically I am converting it into new coefficient C naught, C n and C minus n, and those are integrals of the function f x and the e power case. On the same way, after deriving C n, your C minus n, this is equals to half into a n plus I b n, and again substitute the value of a n and b n. So, that you can write it as half into minus pi to pi f x into cos n x dx plus I into minus pi to pi f x into sin n x dx. Following the same process, I can write down 1 by twice pi I can bring here, half a n will be here, pi will come because for a n and b n 1 by pi is coming. So, that it is 1 by twice pi minus pi to pi f x into cos n x plus I sin n x dx, and I can replace this cos n x plus I sin x by the e power form. So, that I can write down this equals 1 by twice pi minus pi to pi f x into e power, it is plus, so e power I n x dx. So, your C n is 1 by twice pi minus pi to pi f x into e power minus I n x dx, whereas C minus n becomes 1 by twice pi into minus pi to pi f x e power plus I n x. I am just writing C n so that you will understand it better. 1 by twice pi minus pi to pi f x into e power minus I n x into dx. So, your C n is this and C minus n is this. Using these two, I can in one form I can write down 1 by twice pi C n equals minus pi to pi f x into e power minus I n x dx. where for all n which is equals to 0 plus minus 1 plus minus 2 plus minus 3, like this way I can get the values. So, ultimately I am getting one thing, that C n equals 1 by twice pi minus pi to pi f x e power minus I n x d x for all n equals 0 plus minus 1 plus minus 2 plus minus 3, like this way it will go. So, now I can tell that the complex form of, if I say complex form of f x, of complex form of Fourier series, I am writing f s of f x. This now what you can write down? Complex form, simply you can write down f x equals n equals minus infinity to infinity C n into e power I n x, where C n has been given earlier. In the earlier slide we have told what is C n, and if f x is a periodic function, here f x was a periodic function from minus pi to pi, and if f x is periodic with period 2l, say the periodic function with period periodic function with period 2l, in that case I can tell that my f x will be n equals minus infinity to infinity C n into e power, just like earlier we have shown, I n pi x by L. So, here it is I n x when the period is 2 pi. If the period is 2L, this will be transformed to e power I n pi x by L, where your C n can be represented as 1 by twice L minus L to L f x into e power minus will come here I n pi x by L into d x. So, therefore, please note that the complex form of Fourier series of a function is initially whenever it is given in the period 2 pi minus pi to pi, that will be f x equals n equals minus infinity to infinity C n into e power I n x, where C n equals 1 by twice pi minus pi to pi f x into e power minus I n x d x, and it is e power minus I n x d x if the function is a periodic function with period 2L. The changes will be f x equals minus n equals minus infinity to infinity C n into e power I n pi x by L, where C n will be 1 by twice L minus L to L f x into e power minus I n pi x by L into d x. So, I hope it is clear. Let us just go through once the same thing, let us repeat. So, initially if the function is a periodic function with period 2 pi, I can always represent f x as a Fourier series like this, a 0 by 2 plus summation n equals 1 to infinity a n cos n x plus b n sin n x. Now, you know these two formulas, that e power I n x is equals to cos n x plus I sin n x, and e power minus I n x is cos n x minus I sin n x. So, that from here you can write down cos n x equals half into e power I n x plus e power minus I n x, and sin n x you can write down 1 by twice I e power I n x minus e power minus I n x. So, that now substitute these two values of cos n x and sin n x in the given equation 1. Once I am substituting this, I will obtain this equation f x equals this. From here I can write it C 0, I am denoting it by a new coefficient C 0, C n and C minus n, where C 0, C n and C minus n are given like this. C 0 will be a 0 by 2, C n will be half a n minus I b n, and C minus n will be half a n plus I into b n. So, now I am representing the function Fourier series of the function f x in the form of e power I n x and with new coefficient C 0, C n and C minus n. And once I have done it, C 0 is nothing but a 0 by 2, and this value of a 0 is 1 by 2 pi minus pi to pi f x d x. so that you can write it minus pi to pi f x into e power 0 into I x. On the same way, you know C n is half into a n minus I b n. So, substitute the value of a n and b n in the integral form. I will obtain this. From here, I can take f x common. So, that f x into cos n x minus I sin n x, which I can represent it in the form of e power minus I n x. So, that your C n becomes 1 by twice pi minus pi to pi f x into e power minus I n x into d x. On the same fashion, C minus n is equals to half into a n plus I b n. I am just substituting a n by b n by their integral values. Again take f x common, and cos x plus I sin x will be replaced by e power plus I n x. So, that in general I can write down your C n equals 1 by twice pi minus pi to pi f x into e power minus I n x d x for all n equals 0 plus minus 1 plus minus 2 plus minus 3 like this. Therefore, the complex representation of Fourier series of f x, this can be written as in one term minus infinity to infinity C n into e power I n x. And if the function is a periodic function of period 2L, in that case your f x can be represented by summation n equals minus infinity to infinity C n e power I n pi x by L. This is the similar form whenever your period is changing to 2 pi to 2L, and C n will be equals to 1 by twice L minus L to L f x into e power minus I n pi x by L. So, this is the complex Fourier representation form of a function f x, which may be defined in minus pi to pi or from minus L to L. Now, let us take an example. We want to find out the complex form of the Fourier series of the function f x equals e power minus x in the interval minus 1 to 1. Please see that the interval is minus 1 to 1. Let us see how we can get the. So, we know that complex form of f x always can be written as f x equals summation over minus infinity to infinity c power n into e power I n pi into x, where your C n is nothing but half into, here the limit of the integral is minus 1 to 1. So, the f x into, here it will be e power minus I n pi x into d x. So, please note that in the earlier case I n pi x by L was there, here L is equals to 1. In the formula we are putting L equals 1, since the interval is given as from minus 1 to 1. Therefore, L is equals to 1 and the integral. So, I n pi x by L, L value is 1 and this C n is half into minus 1 to 1 f x into e power minus I n x. So, now your function f x is nothing but your f x is equals to e power minus x. So, substitute that value. So, it will become minus 1 to 1 e power minus x into e power minus n pi x into d x. So, that you can write it half into minus 1 to 1 e power 1 minus I n pi 1 minus I n pi into x dx. So, that I can evaluate the integral very easily. So, C n equals, you are getting half into minus 1 to 1 e power 1 minus I n pi into x dx. If I evaluate the integral, I will obtain C n equals half into e power minus 1 plus I n pi. This is e power divided by minus 1 plus I n pi after integration, and the value is from minus 1 to 1. So, that you will obtain 1 by twice 1 plus I n pi will be coming over here, and this you will obtain as e power minus 1 to 1. So, it will be e power 1 plus I n pi and sorry, this is here one x will come, the value of x will be from minus 1 to 1, and this will become e power minus into 1 plus I n pi. This value we are obtaining. So, your C n like this way, if you evaluate this and if you further substitute these values, then you will obtain, you can break it into like this. I am just doing for this one 1 minus I n pi by 2 into 1 plus n square pi square, just you are multiplying numerator and denominator by 1 minus I n pi into, this will be e into this e power I n pi, you can break it as cos n pi plus I sin n pi, you can break it, minus similarly e power minus 1 into, this will be cos n pi minus I sin n pi. So, now you know that the sin n pi value is 0. If I substitute sin n pi value as 0, I will obtain 1 minus I n pi by 2 into 1 plus n square pi square, and this will be e minus e power minus 1 into cos of n pi. Your cos n pi is nothing but minus 1 to the power n. So, since cos n pi is minus 1 to the power n and e minus e power minus 1, I can represent it in terms of sine hyperbolic function. So, that using that value C n, I can write down 1 minus I n pi divided by 1 plus n square pi square into, the value will be sine hyperbolic 1 into cos n pi is minus 1 to the power n. So, therefore, you can write down e power minus x, this is equals to sine hyperbolic 1 into summation n equals minus infinity to infinity minus 1 to the power n 1 minus I n pi divided by 1 plus n square pi square into e power I n pi x. This will be multiplied. So, this is the value of the coefficient C n, and inside summation you have e power I n pi x. So, like this way, this is the complex Fourier representation of the function e power minus x. Let us just quickly go through this one. The thing what we told, f x is C n e power I n pi x, from where C n will be half into minus 1 to 1 f x into e power minus I n pi x, where your L is basically 1, period is L value is 1, because function is defined from minus 1 to 1. So, limit has been changed to minus 1 to 1. For arbitrary case, it is actually I n pi x by L, since value of L is 1. So, we are obtaining this. Now, we try to evaluate this. I am substituting the value of, in the earlier one, value of f x as e power minus x, I will obtain this. Then I am integrating. After integration, simply what we are doing, we are just simplifying the values. In this e power values are coming. These e power values I am just writing the 1 e, I can take it out, and e power I n pi, e power minus I n pi, I can write in terms of cos n pi and sin n pi using the formula. Now, sin n pi is 0, therefore, I will obtain this, and cos n pi is equals to minus 1 to the power n, and e minus e power minus 1 can be represented as sine hyperbolic function. So, that I am obtaining the result as this. So, e power minus x is equals to sine hyperbolic 1 into minus infinity to infinity this quantity. So, like this way I can find out the complex Fourier form of this. Let us take one more function, the complex Fourier series of the function e power a x, where x is defined in the interval minus pi to pi. Let us see that thing. Again proceeding as earlier, your f x is n equals minus infinity to infinity Cn into e power I n x, where Cn is nothing but 1 by twice pi minus pi to pi f x into e power minus I n x dx. Here your f x is equals to e power a x. So, by substitute here e power I x. So, I will obtain minus pi to pi e power a x into e power minus I n x dx. This I can write down 1 by twice pi minus pi to pi e power a minus I n into x dx. If I evaluate this integral, I will obtain from here the next stage, that is C n equals 1 by twice pi into e power a minus I n into x by a minus I n will come after integration, and it is from minus pi to pi. So, that 1 by this will be equals to 1 by twice pi into a minus I n will be coming into e power a minus I n into pi minus e power minus a minus I n into pi, this value. Now, this again I can, using the earlier cases, this you can write down as a plus I n divided by 2 pi into a square plus n square, and this you can write down e power a pi, you can take it common. So, this I can write down cos n pi minus I sin n pi, and minus e power minus a pi I can put it here, and this will be cos n pi plus I sin n pi, I plus I sin n pi, I will obtain this. So, this is I sin n pi. Now, again sin n pi is 0 and cos n pi will be coming. So, that a plus I n by twice pi into a square plus n square into e power a pi minus e power minus a pi by 2 into cos n pi. Cos n pi is minus 1 to the power n, and this e power a pi minus e power minus a pi by 2 is nothing but the sin hyperbolic a pi. So, that you can write down ultimately your C n as a plus I n by pi into a square plus n square into sin hyperbolic a pi into minus 1 to the power n. Therefore, e power a x can be written in the form of sin hyperbolic a pi can come outside, divided by pi will be there, summation n equals minus infinity to infinity minus 1 to the power n a plus I n divided by a square plus n square into e power I n x will be multiplied. So, I hope the complex Fourier form is accessible to you. Complex Fourier form you can understand now much better, and how to find out the complex Fourier form of a function, that also we can do it by this way. Thank you.